No. We're going to do this. The volumes of solids when we know the cross section. So instead of like rotating them and making little circles or discs, we're going to do it when we have the known cross section. But first, our bell work, which means that table's going to stop talking. Thank you. Boys, you're still talking. All right, so if I'm doing this, I got to first figure out which one is the top and which one is the bottom function, right? Right? Yeah. So I changed the bounds. We used these functions before, but I changed the bounds. So instead of checking it at 0.1, I'm going to need to check it between what? So yeah, but negative pi over 2 is the boundary. So I need to be between 0 and negative pi over 2. What's a value that's in between those?
Negative pi over 4.
All right, we could do that. All right, let's do negative 1, okay? That's easier. All right, so negative 1. If I put negative 1 into here, I'm going to get negative 1 plus 2. This one is therefore going to be positive. All right, and this one here, sign of negative 1 would be where? All right. We're going to do this the easier way because you guys are having a hard time. Let's graph them both so you can take a look at it, okay? So we had, what was it, sine of x, which we should know what that looks like, hopefully. And then, what was the other one? 3x. What was the other one?
3x to the third power minus 2x. No, but not 3x.
Oh, no 3, okay. And then minus 2x? Okay. And we're doing this between 0 and pi, negative pi over 2. Oops, I need x equals. And it was 0, right? All right, so we're looking at this section here. Which graph is on the top? There's a green one?
Yes, there's a green, a blue one, and then a red.
So, ladies and gentlemen of the interwebs, we just learned my class is colorblind. There is a purple, a black, and a
Look at
red.
it in the projector. Look at it. That is green.
So they're colorblind. Anyway, it's this one here. The sine, or not the sine, the x cubed minus 2x. This will be my top graph. This will be my bottom graph. Now, just to help you out to look at this one again, this was positive. If I put in sine of negative 1, that means that I'm in which quadrant for sine?
The negative.
Why do I remember?
I have no idea what this one is.
The
The fourth, the bottom one, yes. So in that point, sine is negative, so this one's going to be negative. So this would be my top, and this one would be my bottom, correct?
Yeah.
Amazing. Okay. So that means that I'm going to integrate from negative pi over 2 to 0, and I have to put this one on top. So x cubed minus 2x minus sine of x dx. No squared, no anything like that. This is just finding the area between these two curves. That's all we're doing this time. No rotation yet. Just trying to refresh your memory on this because we're going to do similar things again. Okay. So then, can I integrate? Absolutely. I get x to the 4th over 4 minus x squared, because 2x squared over 2 is x squared. And then this one, minus or plus cosine?
Plus cosine.
Plus cosine of x. Alrighty, and then I'm evaluating this thing from 0 to negative pi over 2. If I plug in 0, that's great. I get 0 minus 0 plus, what's cosine of 0? 1 minus, negative pi over 2 to the power of 4. Well, the negative goes away, but it is going to be pi to the power of 4 over 2 fourths, 8, 16.
Excuse me?
Are we supposed to know like the sign?
Oh, yeah.
Like 1,
Yes, honey.
Yes. So
Without
they
a doubt.
don't give them the circles in Latin.
No. What's cosine of pi over 2?
0.
Yes, it is.
¿Cómo te sabes?
Okay. All right, so that means I'm going to get 1 minus pi to the power of 4 over 64 minus pi squared over 4. That would be my answer. Amazing.
You can just leave it like this.
Oh, hang on. No, I lied. This one should become positive, right? Because I distribute the negative in, this one becomes positive. Yeah, I can just leave it like that. Of course. Look how good we are. We rock.
You know, scroll
Now look at the pretty...
That never works.
Part-time Paulina needs a minute. Part-time Paulina, are you in BC? Or am I going to miss you next year? Excellent.
Yesterday, my friends told me that they were watching the catch-up videos and that we were that my feelings should be heard.
Who said that?
Yes.
All right.
But like crying.
Bring it back, guys. Bring it back. Let's finish the last lesson. Come on. Plus, I drew you pretty pictures.
Yeah.
Don't you love my pretty pictures? All right. So it's not always going to be volumes of solids that are revolving, circling some line or something. We could also do it if we have like different things, like, you know, squares. Where the side length of the square would simply be the distance between the two graphs. Cool. We could do it if it was like isosceles triangles, which would mean that the base of that isosceles triangle is whatever, you know, that is. And the height would therefore be the same as well, right? Why? Well, because isosceles triangle, the two legs are equal. So they got to be the same. All right. So let's actually do that, shall we? Find the area of the square above. So I'm not even going to show you the picture for now. We're just going to look at the square. What's the area of that?
It would be f of x minus g of x times f of x minus g.
Right, which we can write more easily as just square. What? All right, before we try and solve that one, let's talk about this triangle. How is the triangle different?
It's times 1/2 squared.
Exactly. It's the exact same thing, except that because it's now a triangle, it's going to be that same thing times a half. Why? Because that's the area of a triangle. If you don't know that, wrong class. Just kidding. No, you are in the wrong class. You need to go back to geometry, actually, and learn some triangles. Anyways.
In the beginning of the year, you were such a hater.
I was not a hater.
You were
You're
so
still a
like,
hater.
you would be like, you would not be this final.
Listen here. I have sung your guys' praises pretty much all year to everyone. So not even. The only complaint I have is that we're really behind.
We're not behind that, we're gonna finish in the other.
Okay. Anyways, if all of the cross sections areas are added up, so every single square, we add them all up, all those squares, just like we did with the discs, then what would it look like? Well, the volume would be the integral. Ladies and gentlemen, listen up. It was part-time Paulina. Okay, Benji. Matthias. It would still be the integral from the two intersection points A to B, but now it would be f of x minus g of x squared dx. Why? Because remember, the integral is essentially just the addition of all of those things, right? We can write it with some notation, which we've done like once for you, I think, only. But still, we can. All right, so in this case, the one thing we should probably try to remember for ourselves is that A and B are the x coordinates. I'm not writing the whole word, there's no space. X coordinates of the intersection. Or intersections, I should say. Awesome. So, realistically, what would it be for the triangles?
What? The same but times 1/2.
Exactly. And it's the 1/2, doesn't matter where I put it. So let's put it out front so it doesn't confuse us somehow, right? Because if it's just a constant multiplied by everything, we can put it in the inside or the outside. And then the rest of it stays the same. Or KK. Look at us go. We figured some stuff out, right? Look at us being smart. So what were some of the other shapes? I think you guys had said, well, you said what? Squares, triangles, rectangles, and like hemispheres, right? Or semicircles? Well, guess what? We have a different kind of triangle This one's going to be tougher. Or the semicircles. The semicircles are easy. Let's do that first. Part-time poly. All right. The semicircles are going to be a little bit easier, so we're going to start with that one, okay? So with our semicircle, all we're saying is the distance between them, right, is going to be the diameter of that circle, okay? So if we find the area of this semicircle, right, it's going to be a half of a circle. So right off the bat, we got a half. And then it's pi r squared, right? Which means it's going to be pi times the radius. Well, the radius has to be half of the distance between those two graphs. So half of f of x minus g of x, right? And that whole thing, oops, should be an extra set of brackets, sorry. That whole thing then needs to be squared because, of course, it's pi r squared, where all of this is my radius. Now, here's the thing. That's kind of obnoxious, and we can simplify our coefficients and make it easier. So if I have a 1/2 inside here that's squared, what is that really?
It's just 2 times 1. It's
1/4, right? And then we can multiply it by the half that's on the outside and just say, okay, well, this is really just pi over 8 times that very same thing that we were using before, which is f of x minus g of x squared. So do you see how, like, the whole point?
Can you took it out?
Huh?
The square you took it out. I know.
No, I didn't take the squared out. What I did is I distributed the square into the two different factors that are multiplied together, right? If I have ab to the power of 2, I can write that as a squared b squared. So that's all I did, where this 1/2 got squared, which meant I pulled it out. This part, I left it as squared, because it's a lot harder for me to square this until I put in something, right?
But so 1/2 squared is 1/4.
Yep, and then times the half of the semicircle, and that's where I get the 1/8, and then the pi is already there. Okay, now, why am I doing it this way? Because the whole point here is, if you notice, what I'm doing is I'm just creating a new coefficient, right? I'm trying to manipulate it so it's a coefficient times the same thing, f of x minus g of x squared, right? If you look at it, right, like this one is just f of x minus g of x squared with pi over 8. This one is f of x minus g of x squared times half. And this one is just f of x minus g of x squared. So the whole point here is that I'm just trying to make it so that all you got to do really is think about what is the shape and what's the coefficient that goes along with it. Because if you're writing the College Board exam, they're not going to give you these.
So we have
Got to remember them. They are on my wall back there, so you can look them up while you're practicing. All right? So now, yeah, there's exactly, they're just geometric formulas, but we all know that you guys allegedly learned them. All right, so let's talk about equilateral triangles now, because this one's a little bit harder. Because to find the area of this triangle, I need to learn this height, and I don't know it because in an equilateral triangle, this means all of these sides are the same, right? Like all 3 of those sides have to be the same, which means, as well, on an equilateral triangle, because you remember your special triangles, because you allegedly learned them in, geometry. This here would be 30. This here would be 60. This, of course, is 90, right? It's like that special triangle, 30, 60, 90. Yeah. I can't reteach geometry, sorry. I'll talk about it later. It's special because it gives you the unit circle, but, yeah.
What?
Well, because the unit circle is what? We do like 30 degrees, 45, and 60. 30 and 60 come off this special triangle.
No, we never learned that.
That's why I use the word allegedly, because you allegedly learned this, but your geometry teacher may not have taught it. It's very sad for you. Guys, overall, it's not that big a deal, okay? Because realistically, what are you going to do? We're going to work this out together, and then you're going to memorize what is the coefficient I need to multiply by. That's our plan. Okay. So in order to figure out what this thing is then, right, what I would need to do, right, is use the fact that on that special triangle, okay, well, actually, before I do that, let's talk about this. This piece here is going to be 1/2 times f of x minus g of x, right? Hopefully we can all see that part because it's half of the base. Okay, good. So then what we can do is using that special triangle where we know that this has to be 1, then we know that this side is root 3 over 2. So it's root 3 over 2 times that very same thing. So f of x minus g of x. Okay? If that doesn't make a ton of sense, go ahead and do the Pythagoras. I don't feel like doing it. Special triangle, that's what I got cut off for. No, it would not. It's, like I said, later if you guys want, I can go through the actual, like, Pythagoras, but I'm not going to do it on the video. Okay? All right, so now we can find the area of that triangle above. So the area is going to be the base, which is, sorry, it's not 1/2. It's just the whole thing. Well, you know what? Let's do it that way. Let's write it out so you can remember what it is. So that's our area of a triangle, right? Which means it's going to be 1/2. And our base is that f of x minus g of x. And our height is this one that we found. So the root 3 over 2 of that same thing, f of x minus g of x, which we like because now I can get my common the coefficient in the front. So the root 3 over 4 times f of x minus g of x squared, right? So like I said, the whole point is to try and give you like a simple coefficient that you need to memorize based on the type of cross-section, but otherwise it's always going to be f of x minus g of x squared. That's the whole goal here for you. Okay, so if we added up all those cross-sections then, this would simply mean that the volume is going to be that root 3 over 4 times the integral from a to b of f of x minus g of x squared dx. And over on this side, it's the same idea, except that now it's pi over 8 that comes out, the integral from a to b, and once again, f of x minus g of x squared dx. Because again, the whole point is to figure out what do we need for those coefficients, and then the inside is going to stay the same. F of x minus g of x squared. That's our whole goal. All right, what do we notice about the integral defined formulas for finding them? I already told you what is true. It's always going to be a coefficient times.
So,
Exactly. So there's always going to be, why can't I spell coefficient suddenly? Is there 2 F's or 1? 2 F's. Coefficient. We'll pretend that's right. I don't remember. Coefficient times the integral of f of x minus g of x squared dx. So that's always going to be like that. There's some kind of coefficient that is related to the shape, and then times the f of x minus g of x squared. So let's try actually using this, shall we? Region R is bounded by y equals sine of pi x and y equals x cubed minus 4x. Find the volume of the solid formed whose cross-sections are shapes indicated below. So remember, we're not rotating it this time. We're saying that there are specific cross-sections. So in this case, the first one here, equilateral triangle. Without looking, can anybody remember what's the coefficient?
it's pi square root 3 over 4.
Good. And what are our two intersection points here on the graph?
It's 0 and 2.
0 and 2 of, sorry, they were given to us this time, weren't they? So the top one's going to be which of those?
It's gonna be.
Yes.
Why do I know that?
Why do you know that it's sine?
Yes.
The easiest way is to remember that the period is equal to 2 pi over b. So if in our case b is pi, that would mean that we have 2 pi over pi, right? Which means it's 2, and so this is the one that has a full period. If this was my sine function, it's also a little bit skewed, but let's pretend it wasn't as skewed, and you were like, well, maybe that's just like half of the sine function. Well, it can't be because the period has to be 2. It needs to complete a full rotation by 2. So that's how you can tell, okay? If that doesn't make sense, practice your trig error physics. Because allegedly, you've all done this with waves in physics. Yeah, because sine is always going to be like this, and we just need to figure out, like, you know, what is the full period, right? Which just means from point to point. So usually you do like crest to crest or trough to trough, but you can also do middle to middle. And so this is clearly one full rotation. So to find the period, I do this, and my B value is pi, so it's just 2 pi over pi or 2. So I know that this one has to be sine. So that's why it's on top. All right, and then minus x cubed plus 4x, if I distribute that, minus dx. At that point,
It is not squared.
I could actually do this one algebraically.
It is not squared.
Hmm?
No squared.
Yes. Sorry, it is squared. Thank you. Yes, it is squared. I could do it, but not when it's squared. Now I can't anymore. So this would be a calculator question, right? As I was saying, I was like, man, I give you very little space to do this just because it's a calculator, because we don't know how to do it. All right. So we put that into our calculator. So I'll get you guys' help to tell me which one it is here. So it was the square root of 3 divided by 4 times the integral from 0 to 2 of, and now I forget. Sine?
Pi x minus x plus 4x.
Plus 4x?
Yes. Minus 4x. Minus.
Ah, but I distributed it. Yeah, so it is minus, it's x cubed minus 4x, right?
Yeah.
And then I distribute it? Okay, good. Yeah, thank you. Squared. Oh my gosh. Whew, we almost messed that up. All right, so it's 4.321, because in the College Board, we should always do 3 decimals, right? So this is going to be equal to, not 0, it was 4.321. And we don't have any units. They didn't tell us, so we can just leave it. If you really are worried about it, you can say units cubed. But, like, they didn't tell us, so we can just say
So,
unit.
put
Like,
the units cubed.
yeah. Yeah, if you're nervous about it, you could be like, units cubed. Or write out the word units cubed. It's fine. All right, semicircles. Who remembers what the coefficient is? Pi over 8. See, you already remembered. Hasn't changed for these. It's 0 to 2 for our bounds. It's still going to be sine of pi x. That also hasn't changed. Minus x cubed plus 4x squared dx. So we can go back to here. And really, what's the only thing I need to change?
That coefficient.
Good. If you were doing this in your like graphing calculator rather than on Desmos, you can do the same kind of thing. You just highlight it, hit enter, it copies it, and then go edit this leading coefficient or whatever parts you need to. In this case, it's only this. And it was pi divided by 8. And so we get 3.918. And again, you could write units cubed if you're nervous about it. Kind of feeling pretty easy right now, right? Yeah. Amazing.
It's because you're gonna start to rotate it and we're gonna.
I'm not going to rotate these. These are known cross sections. We don't have to rotate. That's what makes them great.
So we would never rotate it in class.
No, de eso fue la clase pasada.
I mean, last class you had to rotate.
Oh, well, yeah.
But when you know the cross sections, no.
But
All right. What about isosceles triangle? Anybody remember what that coefficient was?
1/2.
What?
1/2.
Good. 1/2. And it's still the integral from 0 to 2. It's still going to be sine of pi x minus x cubed plus 4x squared dx. That is a really ugly 0. And again, we can just go back and edit this. Wow, 4.989. Look at us go. What about squares?
It's normal.
It's just normal. We don't have to do anything. It's just like, yeah, man, we got this. I don't know. Just so that you can make fun of me. I felt like you hadn't said anything mean to me for a little while, so I should do something weird so you can say
I
something
am
mean.
never mean. Always. Always.
Can you close your eyes for a second? Can everybody else just do a show of hands for me? Has one of that ever been mean to you? Just raise your hand. I'm seriously the only one? Okay, I got at least a few other people.
Let me go.
Mister, it's just you.
It's not just me. There was 2 other people that raised their hand. They just not at your table.
Okay, that's their problem.
And you know what that tells me? That tells me the girls at your table are just scared of her.
They love me.
Or they're scared of you.
Why do you care? You are supposed to teach us math. You're not supposed to be making
It does
about a student. I'm 17, you're 40. Let's
Oh my god.
contextualize ourselves.
Now you're just being mean again. See? All right. 9. What did I say? 978? 9.978. Yes. Anybody else get Mean Girl vibes just then? No? You guys are all too young. All right. So I am going to throw a little bit of a twist at you, but it's not a hard one, I promise.
Give me a second. I'm still writing because you were covering my eyes. You were being awful.
Wow.
Oh my god.
I'm awful.
That escalated quickly.
I did escalate quickly. Any questions about those four, or does it make sense? Okay. So it's always the same pattern, guys. Find the coefficient, multiply by f of x minus g of x. You just got to figure out the top one. What?
You have to remember the coefficients.
You do. You do. Okay, for the College Board exam, they will not give them to you. However, I will say this. Occasionally, some of them are written in other questions in the test.
What?
Like some of these formulas. So if you do forget them, sometimes you'll be able to find them somewhere else in a question. Not always, but sometimes. Okay? All right, now, we're going to follow the same pattern, but we're going to change it up a little bit. Oh my gosh, it's a rectangle. It's okay. It's okay, look. The rectangle whose height is twice the length of the base. Exactly, it means the coefficient is just 2. Because in order to make the two sides the same, we just had to multiply 1 by 2, and then they're squared. So, it's just going to be 2 integral 0 to 2. I broke someone. Minus x cubed. What's up, man? Pablo, what's up? No, yeah, it's like this is base times height. This is the ratio of base to height. Right? Because one of these would be your base. Or no, yeah, one of these would be the length of the base. The other one would be the height, but it needs to be times 2 because the length is twice the length of the base. Yeah, it's the same thing. No. That would be, I'd have to have a 4. That would be if there was a 2 inside here and it was squared. So because it's on the outside, no, it just means we're multiplying by 2. All right, and then I got to figure out what that one is. So we're going to change our coefficient now to 2. Again, 19.957. Wait, it was 957? Yes. What about if the height is 1/3? This part doesn't change.
Do you have a ruler?
Maybe. I think somebody stole my purple one.
Oh my god, anything that has measurements.
Longer one or that one?
Estos son 10, si estos son 20 centímetros, zapas.
Woo.
I'm amazing at eyeballing math.
Sure. 3.326 for this one. And now, that's it, guys. There's nothing else. So what we do now is we'll just do a couple of practice like AP exam questions.
It's only one.
Is it only one? I thought there was 2.
No, it's only one.
Only one? Oh, look at that. We're almost done. Look how good we are.
Oh my god. So excited. Finally being done.
I know. So let's try it then. All right, from 2010. Before you were all born. Oh, no, it was like when you were born.
The year after we were born.
Yeah, weren't you born like 2009, 2010?
2008.
Really? Oh, look at that. You were all babies. You were all little babies. You were not 2007. Ah, yeah, but there's only 2 of them. All right. I don't know if they're that old. Anyway, in the figure above, R is the shaded region in the first quadrant bounded by the graph of y equals 4 ln of 3 minus x, and the horizontal line y equals 6, and the vertical line x equals 2. Find the area of R. So, first of all, The vertical line x equals 2. Is that like one of the graphs we're using? Is the line x equals 2 one of the like graphs that we're using? No. What is it? It's a boundary point. So that means that I'm really just finding the integral from 0 to 2. Right? From 0 to 2. Why? Because the region goes from 0 to the line x equals 2. Amazing. Which one's on top? The line 6, right? So it's going to be 6 minus 4 ln 3 minus x dx, right? There's no cross sections or anything yet. It's just find the area. Okay. So that would be my area. I mean, technically we could try to do this one, but it says calculator, so let's not. Let's not do that. All right. So this part doesn't change. It is still from 0 to 2, but inside here, that's going to change. All right, what was it? 6 minus 3 minus x, right? All right, we get 6.817. Amazing. 0. All right, we did it. We're done. No, it's true. It's 0. Ln of 0 is undefined. It's an asymptote. All right, find the volume of the solid generated when R is revolved about the horizontal line y equals 8. Oh my gosh. Okay, so we're going to put a line up here, and then we're going to rotate this sucker, which means that we're going to get a shape that's like, why is it something like that? But this is actually like solid, and then this part in here, this is all empty. Right? That part's empty. So it's going to be like this like circular, weird looking donut thing with a big hole in the middle, right? Yeah, I'm fine, man. So that's 7.6. All right, let's find it then, shall we? All right. So when we're doing a rotation, what has to go in front? What's the coefficient? Pi. It's just a circle. Still goes from 0 to 2, right? Now this time, if we're rotating it about this line, which function is now further away? The ln, right? Because what you can do is just always just like draw a line and just closer, further. Like that's all you got to do. All right. So this means we're going to switch it and go 4 ln 3 minus x minus 6. No. Yeah, minus 6 minus 8. That's what it was. There we go. Because you always subtract the two functions, and then we subtract the axis of rotation. Oh, you're right. Yes, sorry. I'm getting ahead of myself. I'm trying to do two things at once. You're absolutely correct. It's this, and then we do the other one, which is 6 minus 8. Thank you. I'm not going to lie. I think I'm as tired as you guys right now. I am not sleeping. Why did I confuse you? No. Look. Okay. Then let me back it up a little bit and unconfuse you, hopefully. Okay, that was 6.187. No, 817. Okay, so remember, this was always pi times the integral from a to b of the outer function minus the axis of rotation squared minus the inner function minus the axis of rotation squared. Does that ring a bell from 7.6 now? And the outer function is the one further away, which is this, minus 8, because 8 is where we're rotating. The inner function is 6, minus 8, because that's where we're rotating. Does that make sense? Perfect. Okay. And, yeah, we're not going to do that. We're going to put it in our calculator. All right, so this is going to be pi. This will be that minus 8 squared minus So what is 6 minus 8? Negative 2, so we can just put negative 2 squared.
Oh my god, Siri is asking me about it.
Cool. 168 points. What does that round to? 180.
Can you actually round?
Well, because it's 189, what was it, 5? So we have to round that because the College Board always wants 3 to 168.190. Or no, sorry, I did that wrong. Did I? What was it again? I'm forgetting. It was 179. There we go. Yeah, sorry. It was 79. 795, which this rounds up to 10, which means that it's that. Okay? Can we see? The region R is the base of a solid. For the solid, the cross-section perpendicular is a square. Find the volume. Oh, that's an easy one, because what is it when it's a square? There's no coefficient. Yeah, there's no coefficient. It's not 0. There's no coefficient. So it would be like 1, technically. And it would still be our 4 ln of 3 minus x minus 6 squared. Did I flip it? Yeah, it should technically be 6 minus that. You're right. It won't matter because it's squared, but well, why don't you try listening? We said technically it should be the other way around, but doesn't matter. No. Because if we square this, because technically we've always done them as like the top one minus the bottom one. So we might as well keep it consistent for our own sake. And then that would be dx. And then we just shove that in a calculator. All right, so we don't need the pi anymore because it's cross sections. And it was 6, 4. Yes. Now, just to prove it to you guys as well, I want to do this. Because I want you to see that it doesn't matter, right? Because if we just have two things subtracted and we're squaring it, we'll get the same answer. But for consistency's sake, let's always just do that outer minus inner, so top minus bottom in this case. So 26.267. And we're done. That's it. Look, you get to go practice.